recording. Hi, we're Team 19, and we'll start our project proposal. Neural machine translation models have been predominantly used in translated sentences, but the problem is that they tend to lack diversity and produce similar results. So the main objective of our project is to increase the diversity of the translated results. So why diversity matters? Because users might want to see different translation results, and providing diverse translations containing the ones that fit their needs would increase their engagement on the system. And also for NLP tasks, the size of the dataset matters, but some languages, for example, Korean, tend to lack volume. And we could generate these large-scale datasets by producing diverse translations.
Let's take a look at related work. Existing research for generating diverse translations can be largely divided into three parts. The first branch is the method to change the hidden representation. This paper creates diverse questions by injecting Gaussian noise into the latent vector. And the second paper proposed multiple decoders as different components for increasing the diversity. We choose this paper as our first comparison paper because this paper is a recent paper and it's often used as a comparative paper in the domain of neural machine translation. And the second branch is a method to improve the decoding algorithm. This paper encourages algorithms to modify the core function in the beam search to generate translations that contain various words. And this paper used repeated beam search to generate various translations. And the final branch is the method to use sentence codes. In this work, they attempt to obtain diverse translations by using sentence codes to control the sentence generation. We picked this paper as our second comparison paper because this paper is easy to implement without changing the model structure, even though they use a different method. So we will try to apply this method to our replication model.
Let's move on to approach. And we chose this paper as our target paper, and this paper was published at AAAI 2020 as a long paper. And the reason why we chose this paper is that the previous works have mainly modified the encoder-decoder architecture to increase the diversity of translation, such as setting multiple decoders. However, this paper do not modify the transformer architecture, but they just manipulate the multi-head attention through the proposed sample policy. So we can easily generate diverse translation without modification of transformer architecture. And actually, this paper shows the best performance among related research. And from now on, we will describe the summary of approach, and our baseline is mainly based on transformer architecture. And in the paper, they said in multi-head attention, different attention had aligned to different word translation candidate. So they proposed a method to generate diverse translation only by manipulating heads. And first, to verify their hypothesis, each head play different roles. They visualize the multi-head attention to see whether different heads play different roles. And as you can see a left figure, each head has different attention that is referring to different words. And right figure is an example of generated translation depending on different heads. And second, after observing each head play different roles, in order to generate diverse translation by manipulating different heads, they propose a sample policy to balance quality and diversity. And this pseudo code represents this sample policy. It consists of three main procedures. They calculate the attention of head H from target side hidden state to source side word. And they count the number of times that word I is chosen from source site. And they sample one of the heads as attention and force other heads to be the same. And lastly, they augment the training data with a reverse translation model and also utilize additional monolingual data.
Right, so then we'll briefly talk about our ideas for improvement. The first is to change the attention sampling algorithm. So currently only a single head is selected, sampled, and its value is copied to all other heads. But instead, we're going to sample multiple heads randomly and use the average value of the sampled heads. Next is to apply sentence codes, which was used in one of the comparison papers, to the current model. And by controlling the semantic and syntactic information on the produced output, we expect a greater diversity in the results.
Now we talk about the data set. We plan to use WMT16 English-Romanian dataset for translation. We're only planning to use one of the 5 datasets from the target paper, as we wish to run as many iterations as possible within the amount of time remaining in this semester. As replicating papers may not work out well within time, our plan B is to use the dataset used in the comparison paper to do the direct comparison. For back translation, we'll be using a dataset that we found since the dataset used in the target paper is unavailable. We specifically chose English to Korean dataset since it's a familiar language with the hope to seek opportunities for further improvement. For evaluation metric, we'll be using diversity enhancement per quality DEQ. We chose this metric because diversity is the major goal of our project and quality is a factor that cannot be compromised. DEQ allows to take both diversity and quality into the consideration. 2 factors are involved: pairwise blue, which accounts for the diversity, reference blue, which accounts for the quality. And this is the plan for our project.